Good evening, ladies and gentlemen, dear students, dear colleagues. My name is Harald Badinger. I'm Vice Rector for Financial Affairs, and on behalf of the whole Rectorate, I would like to welcome you to today's edition of WU Matters, WU Talks. This series has been running for almost 10 years now, and its goal is to make current economic topics of social relevance accessible to a broad public. And thereby, it makes an important contribution to WU's so-called third mission, that means bringing research and knowledge to society. Each of WU's 12 departments organizes one of these evenings during the year, and today the turn is on the Department for Information Systems and Operations Management, and it is dedicated to one of the defining challenges of today's clean energy. Clean energy is no longer just about sustainability. It has become a strategic economic priority for Europe and Austria. The shift to clean energy is transforming industry and supply chains, bringing both challenges and opportunities. Digitalization and artificial intelligence are central to this transition, optimizing energy use and enabling smarter decisions, but also creating new dependencies on data and infrastructure. That is why evidence-based policymaking and rigorous analysis are vital, something WU is deeply committed to, especially in digital systems, supply chains, and sustainability. We are fortunate tonight to have with us Kavita Surana, professor at and head of the Institute for Data, Energy and Sustainability at WU Vienna, who will deliver today's keynote lecture. After the lecture, there will be a Q&A session, which will be moderated by Axel Poleres, head of the Department for Information Systems and Operations Management. I wish you an inspiring evening on how innovation, data, and policy can help us build a clean energy future that is both sustainable and competitive. Please join me in welcoming Professor Kavita Surana. Kavita, please, the floor is yours.
Good evening, everyone. It's my great pleasure to be here. Thank you, Vice Rector Badinger, for the kind opening remarks. I'm going to talk today about clean energy. It's something I'm very excited about, especially the future of clean energy and all the opportunities that lie ahead. But before I go to those opportunities, let's start with a problem. That's the first of the problems. The second one, blackouts. So in April 2025, just after lunch, the lights went out in large parts of the Iberian Peninsula, Spain, Portugal, and even parts of France. Over 55 million people were affected, and the effects lasted over 10 hours. And what happened? The transportation systems went down, communications stopped, and even emergency services were affected. What was the reason? So initial fingers pointed to, was it a cyber attack? Was it too much renewable energy in the system? Was it not enough renewable energy in the system to meet the demand for electricity that those countries had? Was it some failure of algorithms and software that just couldn't keep up? Or was it the failure of legacy energy power plants, such as nuclear, that just didn't perform as they should have? Experts are still looking into it, but they're converging on one possible reason, and that is that it was a series of cascading events that led to this massive blackout. But what I want you to take away from this is the big picture, and that is that energy is fundamental to the fabric of modern life, and without it, we are all going to come to a standstill. And that means it's complex and it's interconnected, and that leaves it open to many vulnerabilities and many risks. But in these risks are also many opportunities. So this talk is going to have 3 parts. First, we are going to talk a little bit about the challenges of the energy system. Then, I'm going to talk about innovation as a possible solution. Or really, is it? And then talk about evidence, which is essential for the future of energy. So the energy system is transforming in many ways. The first is the changes in the supply of energy. We used to rely primarily on coal, natural gas, and oil in the past. These are fossil fuels to meet our energy needs. And this is changing quite rapidly. We increasingly have more renewables, wind and solar, for example, in the system. Now, 15% of global electricity is generated by wind and solar. It's over 20% in Austria. And then when you consider hydropower as well, it's even over 80% from renewables. Globally, wind has grown 3-fold in the last decade, and solar over 10-fold. So the supply of energy is changing quite rapidly. But with these changes in supply, there's also changes in how we transport electricity and how we store it. The energy system is getting more decentralized, so what we used to have is large power plants somewhere, but now some of you might have solar panels in your homes, and that's decentralization. Like other sectors, energy is also experiencing massive industrialization, massive digitalization, and because of the renewables in the system, we need to make sure we also have enough storage, because renewables don't give electricity 24/7. So, the sun doesn't always shine and the wind doesn't always blow, but we always need electricity. And then the third big change is in the demand and end use. So, historically, the need for electricity or the demand was quite predictable. But now this is changing quite rapidly as we have more and more electrification. Transport, for example, is a sector being rapidly electrified and needs more energy. So we used to have more internal combustion engine cars, and now we have more and more electric vehicles. Another big change is data centers. These are central to AI, but data centers are energy intensive. So the more data centers we have, they will also need more energy. A third big change is how we are experiencing changes in weather events. So there are more and more heat waves. These lead to more peaking demands for energy, especially in the hot summer months. So with these changes happening in the broader context, the energy system actually has a various set of problems that are widely connected, but they are a bigger part of the picture. The first one is decarbonization. So burning coal, natural gas, oil, fossil fuels for energy is the largest source of carbon dioxide emissions in the world. These carbon dioxide emissions are greenhouse gases that cause climate change. If we want to address climate change, we need to decarbonize energy. The second and very important issue is security and resilience. So we need to make sure that we always have electricity. We need to have a secure supply of electricity to meet our demands. And historically, this meant making sure that we are secure in the supply of coal, gas, or oil. But now it also means that we have more renewables. Even though wind and solar are quite local, the materials and the minerals and equipment required for them may not be. So we need to make sure that we have security of supply of those materials and of equipment. We need to make sure that we are secure from potential cyber attacks. We need to make sure we are secure from extreme weather events that are getting amplified because of climate change. So more heat waves, but also more hurricanes, floods, etc., that can lead to power cuts. And then with all the other changes, we need to make sure that the electricity grid that transports electricity or energy storage is sufficient to deal with all these changes. The third big issue is access and affordability. So let's talk about access first. 670 million people in the world still do not have access to basic electricity. And 670 million, that's a lot. Population of Austria is about 9 million. So just think about that scale. And it's not just about access, it's also about affordability. Even in Europe, 10% of the population in 2023 could not afford to heat sufficiently when electricity prices were high. So we need to make sure that these challenges are met. The fourth big issue is competitiveness. Now, what does that mean? It's related to many other issues, but it's essentially that we don't want to decarbonize at the cost of deindustrializing economies. Most countries think about competitiveness and technology leadership and preparing industries for the future. And that affects energy. And finally is digitalization and AI. Now, digitalization and AI are affecting all industries. They're making things a lot more efficient, but AI, of course, is also power hungry. And if we need AI and if we want technology sovereignty, it's not possible without thinking also about energy. So these 5 challenges are quite global in nature, but the actions around them have to be quite local because they affect us, or countries, or businesses quite locally. So what should we do about it? My solution to all of it is innovation. Is it really possible? Well, we'll see. But innovation is actually quite central to many policies and strategies that countries and businesses have. In 2024, the European Competitiveness Report, the Future of European Competitiveness Report came out, led by Mario Draghi, that puts innovation at the center as well as energy. Countries, or Europe in particular, recognizes the importance of innovation and how it lags behind China and the US in many ways, given the R&D intensity, that is the share of funding that goes into R&D as a percentage of GDP, is about 2.2% in Europe, but over 2.6% in China, well over 3% in the US, and even 4% in Korea. So if Europe wants to lead, innovation is going to be central. And it's not just Europe, countries worldwide have the same ambition. But does it really solve everything? I'm going to give you 3 examples that show some ways in which it does. So the first example is about global climate change. We know now that a third of emissions related to global climate change or emissions reductions will rely on technologies that are still at the prototype or demonstration stage. So those technologies are still not commercial. And if we want to achieve climate goals, we need to invest and support those technologies so they can scale. In response to this and other energy problems, countries spend more and more on energy-related R&D. So public funding in China, in Europe, and in the US, North America more generally, in energy is growing. The second example I have here is about securing global supply chains. So take the example of lithium. Lithium is a mineral that is critical to batteries. Those batteries power our electric vehicles, and they're also going to be essential for renewable energy storage. But China, and actually a total of 3 countries, have the majority of lithium resources. China actually has over 60% of the refining and controls 80% of manufacturing. So these batteries and the lithium supply chain is very much at risk. One response to this is innovation. So one way to do it is to get rid of lithium and develop alternative battery chemistries. And this startup, Tiamat, it's based out of France. They spun out of a research lab, and they use sodium instead of lithium, sodium being a lot more abundant compared to lithium. Another example is 2Zero, which is a startup from the Munich area, and what they do is that they recycle lithium in used batteries, again securing the supply of lithium. And then the third example is just how Europe is investing in manufacturing locally more advanced and high-efficient batteries that will just secure the supply chain of lithium and for batteries in general. Then let's talk about artificial intelligence. So artificial intelligence is heavily reliant on energy, all the processing that is required. Some projections show how the energy used from data centers is going to increase, primarily driven by artificial intelligence. The increase is going to be mostly in China and the US, according to this assessment. That's because that's where we expect most data centers to be. And by 2030, it is expected that the total energy use from data centers alone is going to be at the scale similar to that of an entire economy, equivalent to Japan. That's the 5th largest economy in the world. And this is an issue that's affecting not just countries, even tech companies realize this. Most of them have decarbonization plans, and they want to be green, or they say they want to be green. But what will they do if they need all that energy? How will they get it? So actually, tech companies are playing a pretty big role in the energy transition, and they are going to be quite important to our future. Amazon is the largest purchaser of renewable energy in the world. Another example is Fervo, which is a geothermal startup which taps into the heat of the earth to get renewable energy 24/7. That means it's different from solar and wind. It's going to be a lot more reliable. And Helion is a startup that Microsoft funded. They are a nuclear fusion startup. And nuclear fusion is different from the current nuclear plants in that there is no radiation involved. It's the energy that powers the sun. And if it works out, it's going to change everything. There will be limitless energy. But all this just to show that how innovation and energy is playing a role in so many ways, in so many problems that the world faces. So there are many conflicting objectives that I talked to you about. Innovation ties them together. But is it really true? And is it an illusion, or is it really that such a big possibility? And I'm going to talk about it in more detail. Innovation, how it unfolds, depends on 3 pillars: technology and manufacturing, investment, and public policy. And it takes decades in the energy sector. It doesn't happen overnight. It takes 20, 30, 40, or 50 years. And I know because I experienced it. So I actually have a PhD in material science. I made quantum dot solar cells. It's as complex as it sounds. I was very excited about it, and I went from working on physics and materials to now being a professor at WEU who works on business and economics and digitalization and energy and sustainability more broadly. And technology or energy innovation is not just about technology breakthroughs. It takes a lot more, and I'm going to unpack that a little bit in more detail. The reason I was excited about solar is that solar and digital technologies actually share a common core, and that is silicon. Silicon is a material, it's a semiconductor, and it's the material that powers both the chips and the processors that we need in our computers, and also solar panels that are really made of silicon. That's how I was motivated to work on it. To work on semiconductors, silicon, change the world through technology breakthroughs. And that was my technology-centric view of the world. So I cared about 3 things during my PhD, which was at the French Atomic and Alternative Energies Commission in the Microelectronics Lab, very technical. But I cared about three things: spillovers. So how do we learn what we have expertise in microelectronics and semiconductors? And then how do we apply it to solar cells, which really need that expertise, where we need those breakthroughs, and where there's a lot less funding compared to electronics and chips, etc. The second, it was about innovation, invention, and technology transfer. So I remember asking a colleague at the time, what would you have liked to achieve achieved at the end of your PhD? And he said, oh, I just want a few patents. And that's actually the environment in which we were in. We were really excited about innovation. Everybody wanted a startup as they finish. We wanted to not just have great papers, but then also, or great startups and great patents, but really think about scaling. How do you go from lab to large-scale manufacturing quite quickly? And because of that, I was also very interested in supply chains. I was working on breakthroughs, advanced solar cells, but they used silicon, and that's the material that is used in manufacturing silicon or silicon-based solar cells across the world. That's what dominates the supply chains. And we thought that if we just get these breakthroughs with the same material and the same equipment and the same supply chain, maybe we will get it faster to the market. But besides these technology issues, I also had a sense of the broader goals. The first being security, where this PhD on solar cells, quite innocent actually, was really funded by the French Defense Agency. The second one being about affordability and access. So I knew hundreds of millions of people in the world don't have access to electricity. They actually don't have alternatives to solar because it's very expensive to extend the electricity grid, especially in rural areas. But even solar is too expensive, so you need to make it affordable. And then the third, of course, on competitiveness. So the countries and the labs and the companies that lead in terms of technology will really be leading in the world. But let's do a reality check. Those solar cells never worked out. But also, I realized technology is not going to solve everything. It actually doesn't solve too much. I had three big insights. The first one was about the supply chains. So China dominates the supply chain for solar photovoltaic or solar panels. In the 1990s and 2000s, the manufacturing of solar panels was fairly equally distributed between China, US, and Europe, and other parts of the world. But come 2010, that's actually right in the middle of my PhD, companies in Europe basically shut down. There was no hope. There was going to be no solar startup, no solar manufacturing, no solar jobs. Everything moved to China. And now, in 2025, almost the entire solar manufacturing and the value chain is in China. The second big insight was on investments. So, of course, energy investments are growing, but they're not always clean. They grew about 8% in 2024 from 2023. But again, not always clean. So the green bars, they show how renewable energy and clean energy is growing, but on top is the brown bar that shows fossil fuel power is still growing. And 98% of coal growth is coming from 15 countries alone. So if we want to do anything about climate change, we actually need to address this. But before we panic, let's be sure these countries are investing in coal for some reason. They're also, China, for example, is the biggest investor in renewable energy technologies. The third reality check is about public policies. So here's an example from the US from onshore wind. And the chart shows how installations have increased every year. Or not, in response to a policy called the production tax credit. Now, what the production tax credit, or the PTC, does is that for electricity generated by a power plant, the power plant owners or investors, they get a certain amount of money for every unit of electricity that is generated. And when there was uncertainty around this policy, the investments went down, and then when there's certainty again, they go up. A few years ago, the US had the Inflation Reduction Act, which made a lot of promises for the future of wind and renewables, etc., in the US, and then projections went up again. But then with the new administration, with the one big beautiful bill, they were scaled back down. So policies are going to play a huge role in the future of energy. All right, now we've talked about the various ways in which innovation plays a role, and innovation has these three dimensions: technology, investment, and policy. But where's the evidence? And this evidence is essential to the future of energy. It's essential because countries worldwide are developing industrial strategies. These strategies are not necessarily about cutting emissions. They are about national competitiveness, they are about technology leadership, they're about other goals. So, for example, the Draghi report on the future of European competitiveness, again, talks about these industrial strategies. But there's always a lot of talk, and what we do as scholars and scientists and researchers is also look at the evidence. And I'm going to talk about three ways in which me and collaborators and others have looked at that evidence for technologies, for investments, and in policy. So let's start with manufacturing. Increasing manufacturing is quite a major priority in Europe. Europe has the Net Zero Industries Act, where it says 40% of the demand of the technologies will be or need to be manufactured in Europe to meet European demand for clean energy. And that's by 2030, so it's actually not that far away. But energy technologies are really, really different. You have everything from large power plants to lighting and solar and wind. So how do we actually unpack this further? So researchers have looked at technology characteristics in the energy sector, and they look at them, they can be defined in two ways. So looking at the simplicity or complexity of a technology, where solar, for example, is quite simple. Most countries could manufacture it. It's very standardized. Wind, for example, has a lot of moving parts, and that makes it complex. Then it could also be seen in terms of standardization versus customization. So solar, for example, could be plug and play. You buy any panels anywhere, and you could put them where you need them. Wind, for example, would need to be a lot more customized. Because wind has a lot more components, it's also a lot more complex in that the innovation happens in different components. There are suppliers all around the world which produce these components, and then somebody brings them together, an original equipment manufacturer, and that's what you see. That's not the case for solar. So that leads to two questions. Should everybody manufacture everything? And then what happens? What is the consequence of this kind of domestic manufacturing? So for solar, some scholars looked into this, and they looked in the past about how the solar supply chain is quite dominated by China. And they looked at the data, and they found that 7 billion countries saved several billions of dollars because of manufacturing in China. 7 billion in Germany, 24 in the US, and even 36 in China itself, compared to the alternative situation where countries would have proportionally increased their own manufacturing. And now, what happens if Europe wants to increase its jobs and have domestic manufacturing as part of the Net Zero Industries Act or something else? Well, Europe could increase up to 44% in jobs within Europe, but this could lead to a small decline globally, but it would come at a cost. There would be potentially an increase of 20 to 30% in the cost of solar energy. Then we looked at wind, me and some collaborators, and because it's so different from solar and the supply chain looks entirely different, there are many components, many suppliers worldwide, we tried to see what would make sense for manufacturing locally. And so we developed this data on wind and looked at how the value chain is distributed worldwide. And what we found is that there are many components, and it differs. So countries need to have some kind of strategy, or companies need to have some kind of strategy about what they want to manufacture locally. Some components, like the tower, that's in the, you see the tower in wind turbines, that most countries can do. It's fairly standardized. If a country or a region wants to participate in the wind value chain, starting with towers is probably a good idea. But if they actually want to innovate, have specialization, lead in technology in some specific parts, you have to go down, you have to look at it differently, and maybe look at something more complex, like gearboxes, where countries or companies could have competitive advantage. Those components require more skills, more resources, more capabilities to innovate. And the consequences are not just on where to manufacture, but also on innovation. So we also found that European suppliers working internationally with international OEMs, so supplying to China or other countries, would have an 80% increase in their long-term innovation. And that long-term innovation is not only important for competitiveness, it's also important for decarbonization, because we still need to innovate to meet future climate goals. The second example I have is about investments. So everybody's excited about startups, me too, or most people are excited about startups. They are nimble, they're small, they can do big things. They can react quickly to market opportunities, unlike large firms. Startups initially often get public funding, but to grow out of that initial stage, they need venture capital investment. And there's generally a lack of venture capital investment, especially at later stages for startups in Europe. So this quote, actually, the EU's venture capital market is underdeveloped, is also from the Draghi report that really specifically points to this. And in response, Europe now has a startup and scale-up strategy. How to fill that financing gap. But energy is different. Energy has had many, many, many failures in the past, energy startups. So venture capital, studies show that venture capital, the standard venture capital, is not really or may not be the right one for energy, where you could have very hardware-intensive needs, or it could be very software-driven. You need expertise in different technologies and sectors, from transport to utilities, to household energy consumption, etc. And the standard model of venture capital that was developed for software may not work for clean energy. And as a result, even though startups are inherently risky and many fail and end up in the so-called valley of death, where even with commercial or market potential, they may not be able to work out and they fail, clean energy startups is even worse so. So we looked into this and looked at what could actually work out. And we looked at corporate investors. So venture capital investors are primarily profit-driven, independent investors. But corporate investors, such as large automotive companies or large oil and gas companies or tech companies like Microsoft or Amazon, they may have other strategic interests. One could be profits, other could be securing their own supply of electricity and their own decarbonization goals. They could be looking into new business models. They could also be looking into it as a marketing opportunity. But compared to the small startups that lack resources, these big companies actually have a lot of resources. They have a longer time horizon, maybe. They have access to supply chains and networks, etc. And we looked into the data on whether this is actually happening or not, and we found that corporate investments in climate energy startups have been growing, especially since 2015. And there are three types of corporates, or multiple types of corporates, but three examples here. One is from energy storage, where a lot of investments came from semiconductor or manufacturing area, both sharing that interest in batteries. So batteries in the phone versus batteries in your electric vehicles, or batteries for storing renewable electricity. A second example is geothermal energy, where a lot of tech funding comes in because they are interested in renewable energy that is available 24/7. And then a third example is in the transportation sector, which got a lot of funding from automotive corporates because, of course, they are interested in the transportation sector. And it's not just this that the corporates are funding, there's actually an impact. So initially, startups get public funding. Then, when they get venture capital funding from independent venture capital that is primarily profit motivated, their likelihood of success or success rate increases by 78%. And if there are corporate investors coming in, it increases by 155%. All that to say that, yes, there is a financing gap and there is a need for energy innovation. But if we look at the data and the evidence, we might actually even find some solutions that work. The third example is about public policy. So again, quoting from the Draghi report, it says we must progressively decarbonize, move to hydrogen and green gases, and do it in a cost-efficient way. Hydrogen is an energy carrier, and when it's generated from renewable energy, it's called green hydrogen. And it's important for decarbonizing some sectors, such as steel or cement. But the ambition for hydrogen is much larger than reality. Only 7% of the projects in Europe, or projects worldwide actually, have actually materialized. So, big dreams, but what should we actually do? And in response to that, in our research group, we're looking actually at this very question. So if you look at installation level, where exactly is the demand for hydrogen? And what could be the cost competitiveness of that demand? We can pinpoint the locations where hydrogen would make sense, where policies should be targeted. So again, there's a lot of thinking about hydrogen, and there's a lot of developments. But if we really look at the data and the evidence, we can actually give quite specific policy recommendations around it. So evidence is essential for the future of energy. It's about innovation, but then that evidence kind of brings together the technology, the investment, and the policy perspectives. But what about blackouts? Well, the next time you experience a blackout, and I really hope that you don't, please remember that you shouldn't panic, but you should really think about all the complexities that are in the energy system, all the things that went wrong, and all the problems that you can solve with innovation. It's not just about technologies alone. Energy is not an engineering or a technology problem. It is very much an interdisciplinary issue that requires people scholars, students, policymakers, business leaders, etc., and of course the members of the concerned citizens coming together to solve the issue. So thank you for your attention. Thank you to my colleagues and the team. Yeah.
Thank you, Kavita. Thanks, everybody, for joining us tonight, and thanks on behalf of our department for the very interesting talk. WU Matters is a format that invites for discussion, for questions, and I guess where there is also a lot of controversial and difficult topics that you mentioned here. Yeah. Particularly trade-offs in terms of what consumes energy, but also technologies that demand a lot of energy. You mentioned AI.
Yeah.
As an AI researcher, I would declare myself. The immediate question that comes up to for me is essentially where do you see actually also AI helping in addressing this, or maybe helping accelerate innovation, and will this be fast enough or something like that?
So that's a great question. There's also no perfect answer to it. AI is helping a lot in optimizing many of the energy sector issues and many problems. For example, in predictive maintenance, or when there's a blackout, you can then figure out with the help of AI increasingly where it is, and that could reduce the duration or frequency of blackouts, for example. But this question about innovation, I find it more interesting because I hear a lot about, oh, AI is going to discover all these new materials and that will change everything. But you have to be careful because even when you discover a new material, to go from that to kind of a prototype and a product and something that is in the market, it takes decades. So in that sense, I think we should just be cautious that it may solve some problems, but not in the near term. In the near term, I think the bigger issue is how do we make sure that there is enough energy or enough electricity for AI. I think in some countries it's okay, where AI is not such a big part of, or data centers are not such a big part of energy consumption, but in others it's quite different. Also, data centers might be quite location specific, and you need to connect them to the grid. And there are already bottlenecks in how we connect different loads or industries that or locations that need electricity to the grid. And now there's more data centers, and I think there's about 20% of them might be at risk to not being connected to the grid. So I think in the short term, the problem is the other way, that we need to make sure that the data centers get enough electricity, or there's enough electricity for AI. And in the long term, maybe AI is going to help with the solutions. But we won't get there if there's no electricity for the AI. So, yeah.
Tricky. So, I'm asking myself, is there maybe somebody in the audience who wants to start to bring up and open a broader discussion? Please.
Hello, thank you very much for the talk. Especially with regards to agentic AI, OpenAI just launched Atlas recently, and agentic AI, at least to my understanding, has a far higher energy consumption than usual AI, and therefore I'm asking you, do the benefits that we, in the end, actually will be receiving through AI, does it really compensate? Can we really afford all of this energy that goes into agentic AI for the benefit that we're getting out of it?
Yeah, great question. I wish I had the answer. I wish I had the perfect answer to it. Clearly, AI has some benefits and also potentially some negative consequences, not just in the energy, its use of energy, but also more broadly. So, I mean, in answer to your question, I would say, business is most concerned about this are the tech companies themselves. They are really trying to solve this issue through whatever they're doing for innovation, because they don't want this trade-off between should we have more advanced AI or should we be using now coal or or natural gas and emitting more in relation to the climate issue. So in a way, if that extra funding comes and helps solve some energy problems, and then that leads to more advanced AI, that's great. But the answer is, we don't know the answer yet. Yeah. Does that answer your question? Yeah.
Hi, everybody. My name is Max, and I come from the energy and infrastructure space, 10 years in that field. Recently, I've been building data centers and developing them, and by far the biggest issue in Europe is connection.
Yeah.
Like, every single operator, data center developer faces that. Microsoft faces like a 10 years delay in the UK, like 10 years. Germany, every single grid connection is overbooked, like triple booked, quadruple booked, six-fold booked, everything like that. Energy storage comes in. A result is that transformers, gas engines, gas motors, like we produce them here in the west of Austria, Jenbacher, Inyo, they become more and more relevant. Nobody's betting on powering a data center with a solar system. Thanks, like that's not going to happen, let's face it. So what do you see? Is there enough policies happening that basically accelerate infrastructure grid building? Because a typical line takes like 12 years to build. A data center takes 3 years, 4 years. So there's a massive gap. Do you see policies happening on European level, state level, to like pick this up sufficiently to basically go in the next 10 years and make it possible to build those data centers, which we actually really need to pick up the issues that we have here in Europe? Thanks.
Thank you. That's also a great question. So I mean, the transmission grid or the interconnection issues are actually one of the biggest issues facing energy. One of the scholars in my research group is even working on it. So there's generally issues about interconnections or building transmission lines, even when it's not related to data centers. This is quite a big problem. There's massive delays. It takes years to get the permits. There's, multiple countries are involved, and it gets more complicated. There's issues in the supply chain. So as you said, transformers are difficult to get. On a different level, there are these interconnections or these transmission lines to transfer electricity, for example, between Morocco and Europe. And a big bottleneck in that is that we don't have enough cables because we can't buy enough cables. Nobody's producing enough cables. So this is a much bigger issue. And because of that issue, there is more focus on the policies around it. With the blackout last year, and then also in the Draghi report on competitiveness, grids are a central topic. How do we make sure that they work, that we can modernize them, integrate data centers or more renewables into those grids, make sure they're working across Europe in a efficient and good way. So yeah, there's it's kind of a broad answer, but this is actually very much on people's minds, on policymakers and decision makers, and then on companies. If you cannot connect your data center to the grid, like I said, 20% are likely to not get connected. There's actually, it's a problem that needs to be solved. Yeah. So yeah, always looking for innovation in that space. Yeah.
Microphone.
Thank you so much for the talk. I thought it was super informational, covered a bunch of different realms and different topics and industries. I had a question specifically about the development of data centers, especially as AI is on the rise. Well, one, I know that you had a chart with the trending growth of energy used by data centers. Do you personally think that it could actually increase in a more exponential rate just because there's so much hype around AI right now and a higher, I guess, increase of that? And then also my second question is, I know you said that the goal is to try to move manufacturing more domestic and more local, but do you think that companies are going to want to build data centers like outsource that in a sense as they become more and more essential for AI?
So the first question was about energy demand because of AI, and if it could grow even more. And it probably could. So currently, data centers, I think, from what I recall, they use the electricity of about 100,000 households, and the largest ones are 20 times bigger. So, depending on how this develops, these are just projections. It could go in different ways. It could be higher demand of energy. But also to be sure, data centers are not the bottleneck to the energy transition. The overall demand from them now is about 1.5%, and it's going to increase a little bit, but not that much. It will be very location specific. So the countries that do have data centers, that demand from data centers could make a really large part of their energy demand overall. So yeah, it could increase and it could look very different depending on where you are, but globally, maybe it doesn't matter that much. The second question, I need a reminder. So I can only answer that maybe in the context of energy. I would think, I actually don't fully know, but if it's not possible to connect your data centers to the grid and there's not enough energy, it doesn't make sense to build data centers in a place where that can't work out. But I think for data centers itself, the issue is going to be, that's another system with another set of complexities on where you should have a data center and why and what are the policies around it. But I can just answer it from the energy perspective. You need to connect it to the grid, and without that, and it shouldn't have other consequences. It shouldn't raise electricity prices. It shouldn't have consequences on energy security around the data center, etc. It could also have opportunities. So some startups are actually working on flexibility in the energy system. So when there's a need for more, the demand is high, maybe data centers scale back their demand, or they have storage systems in place that they can then sell electricity to the grid. So, do various things. But in the context of energy, it's just, you need energy, and there's a data center, you need to match that. Yeah.
Okay, thank you. My question will be, according to the slides, we have seen more information needed, more bytes needed, also more energy. Is there no fantasy, no strategy to reduce energy per teraflop, energy per kilowatt, whatever?
So energy efficiency is I think what you're talking about, and we've made a lot of progress in terms of lighting, for example, or in appliances at home that are increasingly energy efficient. That's the technological progress. But more broadly, I think I'm always careful about it. I'm from India, and I don't know if we can actually reduce energy consumption overall as a country in India, where there's a few 100 million people that don't have access to electricity. So energy consumption for them is going to grow. But in other places, or even there, using energy more efficiently is absolutely, yes, it's an option. Yeah.
This will be the key issue.
Yeah. Mm-hmm. Yeah.
Yeah, maybe as a quick ad hoc comment on that. So that's in fact what for instance, Chip producers and so on are looking into not only, I've just recently heard a talk that was exactly in this direction, that the chip producers are optimizing the data centers apart from the particular chips that you need, for instance, for AI, but also around the optimization of the center is a huge thing where there's a lot of potential of probably reducing the energy consumption by an order of magnitude. So it's really relevant to do exactly this. We have in the very back, we have a question. Thank you.
Yeah, I have a question on your perspective. When China pulls the plug on rare earths, as it does these days, and we don't have semiconductors anymore, what does that mean for our grids and for all of these visions?
Yeah, that's a pretty big risk. That's why. So there's a lot of, I mean, that's also why I was excited about materials, to think about how to develop new materials that in a way reduce some of these risks. And people are still doing that. So for solar, for example, everything is based on silicon now, and people are developing the new material or types of material called perovskites. They're not commercially available, but if they are, they could be manufactured. Or the reliance on the material will no longer, on silicon will no longer be there. And it's probably also similar for semiconductor, or for in the tech industry, for chips, etc., to develop alternatives where you don't need those specific materials. But for or for chips to work, you do need semiconductors. You might want to look at different types of semiconductors. There's also other things that countries or companies are thinking about, so recycling or alternative materials, and then also just manufacturing more within Europe, kind of stockpiling the materials, etc. So various options, but it's a major risk and an area of high vulnerability.
Thank you for the talk. Maybe also similar to the question about efficiency, my hope is also that maybe we don't have to produce that much more, but we can also make use of more storage, especially when it comes to green energy. We see the demand and the supply of green energy don't really match. During the day we produce much more, especially from solar and stuff like that. So what's your hope when it comes to batteries? Do you think it can improve the situation much more? Do you think it's useless and the efficiency gains are too little, or not the efficiency gains, but because efficiency makes it being lost, then it doesn't really make sense to invest in it? Yeah. Oh. And I'm not only talking about lithium batteries, but general batteries.
So we need storage for sure. I mean, if we need, we need to meet all those energy goals. Storage actually is quite key to ensuring we have security of energy supply. Lithium batteries, the cost has gone down quite dramatically in the last decade or so. But that's primarily, it's worked out for electric vehicles. But if you want to store electricity in the grid, using lithium is still quite expensive, especially if you think about longer duration. So, I don't know, half a day or several weeks or several months. And in that case, people are developing other kinds of storage to see what could work out. And some of that doesn't rely on lithium. I mean, actually, there are what are called flow batteries, that they could be made of organic materials that could be manufactured in Europe or anywhere else. So it's also thinking about reducing that reliance on lithium, developing new approaches, and then making sure, I mean, like I said, it's, I can talk a lot about technology, but it really doesn't matter whether it works or not. It has to be cheaper than the alternative, which is not green. So the goal is to make it cheaper, and you need the policies and investments to do that. And if it's too expensive right now, doesn't mean it will always be too expensive. as they scale and people learn how to use it, and manufacturing increases, etc., costs always go down. So there is hope. I just don't know how long it's going to take. Yeah.
Hi, thanks for a great talk. My question is, I mean, we've been working with in a project that's dealing with or have some interaction with this concept of local energy communities. Just wanted to ask you whether this is something that you see in the future could affect like this dynamic with the energy, because it seems to me that something with the management of energy, it might help. But currently, I don't know, it seems to be just a concept or not much implementation. Thank you.
Thanks for the question. So I don't actually work on local energy communities, but I can give you my opinion on it. I think it's great. People kind of want to have these communities that have their solar, and then their storage, and then it's optimized in a way that you have energy management systems for an entire community. You can buy and sell from the grid, etc. You can be independent of the electricity grid. I think these are really great solutions at the local level. But for kind of this large-scale change, so when you think about all the problems that are kind of global in context, and you think about change at that level, everybody, or we need a very large number of energy communities for that. So I'm not sure if it's going to be able to scale in that way, but kind of for local needs, it's an excellent solution.
We had some questions over there. Yeah.
Hello, everyone. Thanks a lot for your talk. My question is mostly on the ethical way. We know that in order to produce or improve something, we should money. It's like the cost of question. And it's inevitable for corporations and even for the country, in order to invest money for clean energy, we should cut the expenses somewhere else. This means that for corporations, it's firing a lot of people, or for country, it means the cutting for social expenses. And I want to know your opinion for the future, how it can affect for the people the cost of our clean energy.
That's a really great question, and also a very tough one. I think in some of the countries where resources are for critical minerals or raw materials, the way mining happens is not, is not ideal, and it's not for the benefit of the people who live there. It's for the benefit of the companies who need it. I think the issues that coal mining or coal power plants have faced in the past are going to be quite similar for raw materials or critical materials going forward, in that there's health impacts and that there's societal impacts around it, especially for people who live around these places, but they also benefit in some places from the job opportunities. But the large-scale impact of that and how people and societies are affected in different countries, I don't really know the answer. I think it's a really important question, but I can't tell you more. I think we have to, I mean, from my experience and my research, which is more focused really more on the energy side rather than the mineral side, I think there's a history of this also in oil, in coal, etc., and it's never been very good. So I don't have a good answer for you. I'm sorry. I wish I knew better.
Hi. Yeah, thank you for this very informative talk. I was intrigued by one of the statistics that you were showing, that a lot of the solar panel production has moved to China and more or less shut down overnight in Europe. So is that a problem from a European perspective, and were there any learnings for European policymakers?
Yeah, that's a great question. So Europe now wants to start again solar manufacturing. I think there's some productions already planned in Germany and maybe also in Italy. And it's great to have local manufacturing, I mean, for other objectives. But I think it is, in my view, it could be a problem because I'm not sure if solar is going to stay as cheap as it is because of the manufacturing in China. So you can have domestic manufacturing and then you will have more jobs and maybe you have more security of supply for solar panels, but you're going to have more expensive solar electricity. So, in the study that I had shown there where they look at possible job increases in Europe, that was about up to 44% increase. But then they estimated what is the cost increase, and that's 20 to 30%. And yeah, so policymakers, they need to think about it. You can get a win in terms of security of supply and an increasing jobs, but are you willing to pay for the extra cost of electricity? And then will people use less because it's more expensive, and then kind of defeats the purpose. So I don't know how much they're thinking about the costs, but they're definitely thinking about local manufacturing. Yeah.
Yeah, thank you for that lovely talk. I just wanted to ask you a more general question, not too technology focused. I'm not too well educated on that topic, but just wanted to hear your opinion about the global carbon market, how relevant you think it is, how faulty you think it is, or actually helpful it is, especially over the next few decades, especially for big corporations just buying more carbon credits. But yeah, just want to hear your personal opinion on how much it actually does for the market.
So, as far as I know, it's I mean, there's. Are you talking about carbon removal or carbon?
Buying carbon credits to offset or
carbon offsetting.
Yeah, yeah. So I kind of stay away from this because I find it to be quite controversial overall, and I think recent studies have shown that what corporates have claimed or what we have claimed as carbon offsets didn't actually quite work out in that way, and that's my level of opinion. I think we are better off decarbonizing than kind of buying carbon offsets from somewhere. Yeah.
There were more questions.
Hi, thank you for the talk. One kind of broad question from me. You talked a lot about how innovation is kind of the thing that we should be looking for in the way that we solve a lot of these energy problems. But I sort of question sometimes whether we put too much emphasis on innovation. I mean, there's kind of the issues that we hear are things that we already know a lot of the solutions to, transmission connections for both customers or generators on the grid. We know how to manufacture solar, and yet there's plenty of communities that don't have access to electricity, all of that. And I kind of wonder what your take is on whether sometimes we jump too much to the new kind of sexy, cool solution. For example, something like hydrogen, which isn't really working out the way that people projected it would, but we poured lots of money into it and it was seen as the next kind of new big thing. So I was wondering on your perspective of how much we need innovation to solve those complex problems, but how much we should be focusing on things we already know the solution for.
Yeah, that's a great question. So for me, as I said, I need one moment. So yeah, innovation doesn't solve everything, and certainly not technology innovation that solves everything. You actually need innovative policies and innovative business models as well to do it. And so that's my view on innovation. You can't just say, well, we've solved the technology problem with solar, and so, we're going to get there. That's not how it works. But the other aspect of this is the data and the evidence. That's also what the kind of research I do, because we're spending a lot of money on various things. Does it even work? And what can we say about it? And that's important to understand as researchers and scholars, that where is the evidence, where is the data? And actually, sometimes the data and the evidence on this is really hard to get. we often build new data sets and put them together to get to that evidence. So I fully agree with you that innovation is maybe not the, it's not the solution, but it's not technology innovation that's not the solution. Innovation more broadly is we need to think about these problems in an innovative way, in an interdisciplinary way, and there's no way of solving them without evidence, and that's kind of the other aspect of it. We need data, we need like very rigorous analysis to know what's really working. Should we put all money on hydrogen everywhere, or should we be pretty targeted about it and do it in a really good way? And then to be targeted about it, you kind of need to work it out on where that is needed.
There was another question just behind you. Yeah.
Thanks as well for your talk. My question kind of relates to the previous one, and that is that innovation, you put a big emphasis on it and said that most of the innovative thoughts that are currently happening or taking place are still like in a they're not commercialized yet, they're still in research. However, we see with like Hurricane Melissa currently taking place that we need immediate action in order to reduce carbon emission by 45% till 2030. What are the key facts or key things that need to happen in the clean energy department in the next 5 years to, I'm not even asking if it's a realistic goal anymore, but just what do you think should be happening within the next 5 years to kind of target that goal as best as we can? Thank you.
So my first answer to that is data, evidence, etc. Lots of possible solutions. I mean, also building on the previous question, lot of possibilities, lots of talk. If we want to act on it, we actually need the right level of data and the right level of evidence for the right level of action. And then the second big thing, I think, is transmission. So we've talked about it in the context of data centers and connecting people to the grid who don't have access, just in ensuring that the grid is modern and is able to deal with the changes that are happening in the energy system. That's the second big thing. And then I would say, just making sure we meet the demand for electricity all the time, and that will require some storage, it will require flexibility in the grid, it will require changes in markets to not have the kinds of blackouts that happened in April in the Iberian Peninsula. So these are kind of three things that need to happen in the next 5 years, in my view. And then one bonus thing, and that is actually climate change is happening. We are experiencing all of its impacts. You talked about the hurricane Melissa, and then there's heat waves or strong winds, etc. We need to be able to adapt to that quite quickly because we are not, even if we do meet climate targets, these experiences are already quite present and amplified in the world. So that would be my suggestions for the next 5 years.
Hello, thank you for your talk. And I have a question regarding policies. How much influence do you think does it have on this whole field of problems, basically, on electrification and decarbonization, the spreading of misinformation about the technologies involved? Because, for example, I've always been very interested in this whole topic. For example, electric cars and alternative heating technologies like heat pumps. They are technologically feasible, they work perfectly well, but still, whenever I scroll through newspapers, I always see those articles saying, yeah, electric cars, they don't go far enough, they are not viable in the winter, which is crazy actually, because I drove to Norway in my electric car and back. Must have been in my imagination, I guess. And also my parents' house is pretty warm for being heated by a non-working heat pump, as we know. So yeah, I'm wondering what's your opinion on the role of misinformation and such.
Yeah, that's a great question. I mean, misinformation is a much broader problem, not just related to energy and climate. And there's also a lot of climate deniers in the world. And my approach to that is I want to try to frame these issues around opportunities rather than get into those discussions. And those opportunities are, well, if there are more electric vehicles, can we also talk about, I don't know, can we start to think about more jobs or more local benefits from that, or something around that narrative that people would actually like, even if there's some alternative version of electric vehicles discussion going around. So that's my approach to it. I just want to think about it in terms of opportunities, and that's why in this talk I also wanted to talk about solutions. We can always talk about problems and all the things that are going wrong, and there might be some little bit of truth to it, but mostly it's a lot of it is misinformation, as you said. But what's actually the benefit of decarbonization? And for me, the big one is these are all industries of the future. They're not legacy industries. And if we want to look ahead, and if we want to see where the world is going and be part of it, you need to start embracing electric vehicles or green industries, etc. That's just where things are going.
Hi, good evening. Thanks for the talk. My question comes back to the policy matter. So there are so many discussions about the uncertainties related to the sector, about costs, for example, and how the energy will be produced in the future. So I want to hear your opinion about the conflict of interests between public and private sector. How do you see that, and how much these conflicts are impacting the development of more efficient policies to boost the sector?
Mm-hmm. That's also a really good and very important question. Of course, there are many conflicts. So, the public sector is looking for public good, and private sector is looking for profit, just broadly speaking. And again, my approach to this is how do we bring that together? So, and that's kind of the reason why I talked about this example of corporates investing in climate and energy startups. They can benefit, so that's the private sector. They can benefit because maybe they will make some profits out of it, but they will also have access to new business models and new technologies, and they can talk about their own decarbonization goals. But ultimately, it's around public good, and that is clean energy. And I think policymakers also realize that, and increasingly there are efforts to bring together the public sector and the private sector together to meet these specific societal goals. And often that is industry specific. So there's something called the First Movers Coalition, and that's where a lot of the large corporates come together, along with certain policymakers, for example, for aviation. So what can they do together to decarbonize aviation, for example? So the point being that you're right that these interests are not aligned, but then it's important to think about what can align these interests, and then how do we bring that together to reduce emissions, but then also make sure the shareholder interests are met and the profits are met, and there's no negative impact on society. The issues in mining, etc., those don't happen. And it's not easy to do all these things at the same time. So, and that's where kind of comes the role of the scholars and researchers, where we look at evidence of where these trade-offs are.
Hello. So my name is Maksuda, and I have a question. It is basically as you mentioned, first thing that you mentioned is about the blackout, right? So when I heard it, I saw everyone's reaction, and it was kind of funny to me because I belong from a country which is Bangladesh, where blackout is very normal. It's like every single day we have blackout for at least an hour, trust me. And except for some places of the capital, of course. So my question is, as EU is in leading decarbonizing as an energy access and everything else, how do you think, like the countries like Bangladesh, maybe India sometimes, some part of India, Pakistan, especially the South Asian countries, except for few, how, as we are struggling in accessing this energy, basically, how can EU policies or strategies can help to avoid this? And how can this also help us to, you know, access enough amount of energies in our home countries too? Thank you.
Thanks. Great question. I'm from India, as I said, and I also grew up with power cuts every day. I think it still happens, but when I was growing up, it was sometimes even overnight. So, you know, I know the feeling. So the countries in South Asia, I mean, India, as I showed earlier, there's a lot of coal power development going on, but actually it's very easy to say, well, why is there coal power? You have to remember, as you said, these questions about energy needs and energy access, and those countries are also investing heavily in renewables. What Europe can do to support that, I think there's companies that go and invest in South Asia, but then there's also a lot of development financing that which goes to support in support of renewable energy power plants or in support of decarbonizing goals. And so typically or often they don't fund the coal power plants, they fund the renewable energy power plants. Then there's also a lot of technology transfer, so things that are developed in Europe or European companies that should and could be transferred to South Asia or Sub-Saharan Africa, and that also might help achieve those goals.
I think one more. We can.
Thank you for the talk. Thinking long term, what do you think the future of energy will be? Will we have a diversity of energy sources, or will there be a breakthrough in energy on a specific energy source which will dominate the future?
Well, as a former physicist, I love nuclear fusion, and if we kind of magically, you know, have fusion, so it's not the current nuclear that we have that's fission, it's just what powers the sun, that's going to solve everything. But realistically, I don't really, I would personally not bet on it. I think we need all possible solutions, because if we were to just think, okay, this one technology or one possibility is going to change everything, that may not actually happen. So we need to put our money everywhere and hope that all of it works or one of it works. But I don't think anybody knows that answer, so I also don't know that answer.
Thanks a lot. So thanks a lot, everybody, for all the lively discussion and the many questions. Time has flown, I'm just seeing. What I would take is, I guess, as a summary, if I may. Yeah, so, all these questions that were raised need data and evidence, which you emphasized several times, and respective policies to prioritize correctly. We have a lot of open questions, not only technological questions, but these policy questions, societal questions that are still unanswered, that will need interdisciplinary answers, that will need ideas, which is also the name of your institute, right? And innovation. And I guess that with all the interest of the audience, we hope we also leverage this innovation here at WU with our students. Thanks a lot again. Big applause also again to Kavita. Thanks a lot.
Thank you.
And thanks to everybody, and we all deserve some refreshments, which we still have there in the back, and we hope that we can invite you to stay a bit and talk with us also informally afterwards.
Thank you.